So Google Summer of Code is a kind of internship program. You're not an intern at Google, but Google pays you an internship stipend to work on open source projects. There are many open source organizations participating, and each organization accepts students working on their own projects that they propose, on projects that the association for us or the organization for other open source projects proposes, and students can pick something they like and then apply with the organization, and the best ones get slots in the end and work over the course of around 3-4 months on open source projects.
They also need some kind of supervision. That's where all the mentors come in.
Yes, there are
that
people
we have to supply to them.
Exactly. The organization provides people that guide the students or hold hand in difficult times and explain the things or work with them on the task. These are called mentors.
Yeah.
Indeed. This year we have 6 projects. These 6 projects are, as we said already, the USB-free software. There's another guy working on lossless JPEG image compression in the FPGA inside the AXIOM Beta.
That's JPEG 1992.
Exactly. I guess that's the year when the standard was established, or when the method of compressing stuff this way was envisioned.
Well, I only know JPEG 2000, actually, because that's how young I am.
Oh. No, I was also surprised. JPEG contains a lot of different compression methods, actually, and what we use as JPEG is just one of many.
Yeah. Like a DCP, a digital cinema package, is also JPEG 2000 because it really compresses nice.
Yes.
And you can have very good looking
Indeed,
footage.
but JPEG 2000 is lossy compressed, very well compressed, but it's a lossy compression. And in contrast, the JPEG 1992 method is entirely lossless. So it doesn't reduce the amount of data that significantly.
No.
It goes down to, from initial tests that we've seen, to around 50%, 60%, 70%. It depends on the image content. So if you have a lot of details, like fine contrasts or fine details, the data rate rises. But if you have very smooth, like same color surfaces, if the image is basically white, in worst case or in best case for the compression, then it reduces the data tremendously, basically. So that would be very interesting, but
I guess that's why he also chose 1992 and not 2000.
Probably. It was his own proposition, which is very cool, and we're happy to support him, and he's doing very well. We even have some pictures of him working on the hardware and the software, which we'll happily show here. And if everything goes right, the AXIOM Beta should be able to integrate his project so far that we can actually compress footage that again could be streamed over USB 3 with his encoding methods directly in the FPGA. So it's lossless compression in the FPGA without any CPU usage.
It's very impressive.
Yes. So another student in Google Summer of Code currently is working on the bidirectional FPGA communication protocol.
You explained it to me already one
Yes.
time, but
Yes.
please explain it again, because I have no idea.
Happy to, because I also need reminding what it actually is. Now, if you remember the layout of the AXIOM Beta main board, there are 2 Mach XO2 FPGAs underneath each shield slot. And the bidirectional FPGA communication protocol is meant to package certain communication interfaces that the shields can communicate with or request to communicate with. And it packs it kind of basically into the data highway between the main FPGA, the sync, and the XO2. So it pipes that communication through a common bus system, and in the end you get again like I2C or SPI or whatever communication interface you want on the shield slots. And that project takes care of all the in-between, basically. Other projects during GSOC, Google Summer of Code this year, relate to working with the AXIOM Remote software.
How is that coming along?
Also doing fine, I think, yes. Extending the camera control daemon.
Yeah.
The control daemon is kind of the central junction or API for setting anything the camera can control. So that has been extended. There are different kind of communication modules in daemon. One is supposed to work with a web interface. One will in the future work with the AXIOM Remote. There's a command line interface and so on. You can extend that easily by just adding a new path into the control system, basically.
You can talk to other things like measuring exposure or something.
Exactly, or temperatures in different places in the camera. It all goes through the control daemon. That's the plan. It's still in development, but it's progressing.
Very good.
The frame server for OpenCine is currently being developed.
Okay.
So if you shoot raw sequences with the AXIOM Beta, you need some way to play or edit these things, and that's where OpenCine comes in as a kind of raw viewer and not too sophisticated, but a simple editor for raw development. And the frame server is a kind of layer underneath that does live transcoding of the raw footage. So the idea is that you have like a QuickTime container, MOF, or an AVI container, or whatever the container is. And the frame server takes care of providing the actual content of that container by reading data from the raw or original footage. So it's like a virtual movie clip that you can load in any software that can read QuickTime formats, basically, but you still read the actual raw data from the original raw recording.
Cool. Very
That's very good, yes.
Yeah.
So that rounds up GSOC for this year.
How many do we have?
6 students in total.
Wow. That's a lot, isn't it?
Last year we had, let me not say something that I can't have to revert back again. Last year I think it was 4 students.
4 students.
4 students.
More is more.
Yes. Next topic I have here is a 3D printed enclosure prototype of the AXIOM Remote.
Oh la la.
And as you can see in this latest concept rendering that we're showing right now, we simplified the design a bit. There were buttons on the side previously, buttons on the top, several
We need more
buttons
buttons.
everywhere. But in the course of the development, this actually comes from the progress of creating the hardware and creating the software of the AXIOM Remote. I just couldn't find applications for some of the buttons or the rotary encoders.
It doesn't matter, we need more buttons.
Yeah, let's add more buttons there. So in the next revision, we will actually have a lot less buttons. Also, the slide buttons. It's quite a challenge if you think about slide buttons on current cameras or other devices. You never know in what position they are. Sometimes they add a color to the slider so that if they are in one position, they light up orange, for example. But what does orange mean? On or danger, or is it off now?
Probably everything.
Yeah. Or then you have, for example, for locking devices, closed lock with the pin inside on the one side, and the same icon with the pin not inside but outside on the other side, which is super confusing because you have to look very closely, is the pin in or out now, or where's the lock, what does the lock mean? So we actually opted for not using slider buttons anymore, but for push buttons, which basically do the same thing, but we can in the menu or by lighting up the buttons show if it's in effect or not. That's simpler, easier, and has the same application or same use actually.
But we still have flip buttons, do we?
No flip buttons.
No
anymore.
flip
Sorry,
buttons
flip
anymore.
buttons are all gone.
All right.
So reduced it down basically to the LCD, buttons around the LCD, which do the main functions on the remote, because the LCD always shows what the button does.
Yeah.
So the big kind of outline of how I designed everything is that you always see what you're doing if you press a button. Because I hate nothing more than operating cameras where custom functions and custom buttons do something where I don't know what's happening.
Why is the button free? What more information do you need? But actually what I miss about the physical buttons is just the haptic feedback. So
Indeed.
you have to only feel it and you know what mode it's in or something.
Yeah, that's also an option, but then we need the rocker switches again.
All right, let's
Yeah.
get
Here you have to look.
go back to the drawing board.
Let's start over. And what I reduced it down to is the buttons along the LCD, the record button, obviously, photo button or still button, the rotary coder, which is the main kind of way of getting around the menus. It's also pushable, so it does pretty much everything. A power button and a lock button as replacement for sliders, which do the same thing. And that's it, basically. The hardware for the current version is finished, and now we are working on a next generation hardware that throws out all the buttons and does all the small minor corrections and improvements, like no slider button anymore, but the push button instead.
Yep.
The button itself is also quite a challenge, as it turns out the illumination of buttons, which we want to have, so you can also operate the AXIOM Remote in darkness or in dark environments, so everything has to light up. And that's quite difficult to create, actually. If you look on electronic distribution websites and you go into the switch or button subcategory, you get thousands of different options. They all look almost the same. The pushing pressure is different. The shape is similar. Some are flatter, some are a bit more thicker, but there are like endless options. The moment because you have a lot of filters and you can switch, I want this shape, and different options. The moment you switch to illuminated buttons, which integrate an LED inside the button, kind of, that thousands of options suddenly go down to 10, 20, maybe 100. But then when you go further and say, I don't want a THT, but an SMT option, what is it? THT is when the pins go through the board, which is a lot more complicated to solder automatically, in contrast to surface mount technology components, which kind of float on the surface of the PCB.
THT, through-hole
technology.
All right.
SMT, surface mount technology.
Makes sense.
So if you do automated assembly like we want to do, SMT is the way to go because it's much simpler, quicker, cheaper, everything. So if you dial in illuminated buttons and I want them to be SMT only, then it suddenly gets down to a list of just a few options depending on distributor.
Okay.
And they get quite expensive, unfortunately.
Imagine.
Like normal push buttons, a few cents, 10 cents or so, no big deal. But as soon as you match for SMT and illumination, it gets, depending on how many buttons you want here, quite an influence on the material cost.
So every circuit board or every device that has an illuminated button, it has one of these buttons.
Well,
is there another way?
There is another way, but that's, as we are currently discovering, even more complicated or challenging, because you can of course place normal LEDs, which also cost pretty much nothing, even the SMT options, close to where the buttons are.
But then you need multiple ones, I guess.
First you need to spread them out, yes. And now comes the difficult part, you need light guides.
Okay.
So these are small optical elements that take the beam of light from the LED and redirect it to where you actually want the light, like the button. And these are optical devices, so very hard to do DIY. Can't just 3D print them or so. We tried, and it depends on the...
It's like fiber optics. It needs to be...
yeah, it's fiber optics, sometimes silicon-based, but reflective surfaces need to be very smooth, polished. So that's not something a 3D printer can do. So we are currently experimenting with either using off-the-shelf existing light guides, we do 90-degree angles, for example, to at least get the light from a LED next to the button into the button. That's one of the options. Or we want to do, like in previous team talks we've already shown, casting of light guide material from silicone-based materials.
Okay.
So like the heatsink, we did injection molding previously. We'll see if we can actually injection mold light guides. I don't know if it will work, but we will try.
Back to the tarmac. And
Yes, indeed. So several approaches like off-the-shelf light guides. Will they work? We'll see. Custom-made light guides.
Yeah.
I hope the surface finish and the reflectance and everything can be done DIY.
Yeah.
Or if that doesn't work, we need the expensive illuminated tactile switches.
We've built in light guides.
With the LED basically in the center of the button.
Oh, really?
So you don't need to direct it anywhere. It already is where you want it to be.
Well.
Well, cheap, expensive, easy, difficult. So many parameters.
Yeah. But it's fun to experiment.
Definitely. And we will learn a lot. If everything fails, the buttons will stay dark. We'll see. At the back of the AXIOM Remote, you probably noticed this weird thing here.
Yeah.
And if you didn't know what it is, you would actually think it's a battery, like this, a V-mount battery.
Isn't it?
It isn't. It's the AXIOM Remote. I looked long and hard at off-the-shelf solutions, how things can be quickly attached to each other, like hinges or quick lock solutions. And the surprising discovery is there isn't any real off-the-shelf solution. I found nothing. There was a solution for fishers who want to attach fishing rods to their boats. So they had something that's slightly larger than the V-mount, like a huge metal triangle.
Okay.
So you could attach the rod and then catch the big fish.
Never saw
But
that.
for small, like household, kitchen or electronic utilities, there's nothing. I don't
It's
know. Everyone
not
does.
built for sturdiness.
Everyone
It's-
does his own thing when things need to be attached. It's a bit tragic, but that's the way it is. But the way of attaching a battery to cameras is well known. And the V-mount plate is easily available. You can buy it. And that works really well. You can attach with a simple V-mount plate the AXIOM Remote to a future attachment point on the camera. It's the way forward.
And then you still have to attach it to the camera with
But
a cable.
There is still a cable solution currently envisioned. We are thinking about using off-the-shelf solutions again, because obviously we could build a super specialized cable that costs as much as the actual remote. LEMO connectors, high sturdiness, metal jacks or anything. But would that really help or solve it? I don't know. I'm a very big fan of using existing cables. And what's really convenient currently is USB-C, because you can attach it in both ways, obviously. And it's pretty small connector, but very well built. It's pretty solid metal, in contrast to the micro or mini USB connectors. And that would be a way of connecting the remote to the AXIOM Beta, but also the remote to a PC or any other device which could be controlled through the remote. It's not a device specifically only built to control the AXIOM Beta. There's a small microcontroller in there, so you can communicate with a lot of other devices. I guess people could use it as a musical instrument maybe, or remote control washing machines. I don't know. The sky is the limit. But USB definitely makes it as simple as possible to interface it with pretty much anything else.
Yeah.
And the USB-C, since you can flip it, I designed the enclosure in a way that you can attach the cable in multiple positions, because you never know, will the remote be at the bottom side of the camera, on top of the camera, on the left-hand side, on the right-hand side, and so on. So I made the attachment point, or currently it's envisioned that you can route the cable out in 3 different ways. So if that works out with the flipping of the cable, it should make it most convenient to attach and route cable from remote to the Beta.
Well done, nice.
Thank you. Next steps, next revision of the hardware, next revision of the enclosure, then actual metal prototypes, when we figured out the illumination challenge.
Yeah.
And there is already the hardware for the current setup, and that's already working.
What about the software?
The software is it's a PIC microcontroller, 32-bit microcontroller, runs the current software bare metal, so to say. There's no operating system underneath. And I already created a menu structure. You can go through different submenus, a different hierarchy. You can use buttons as well as the turning knob to navigate. There's a demo kind of current content where you can set white balance, which doesn't currently do actually set the white balance because the communication with the camera is still not working. It's still its own independent device. But you can set menu parameters through different pop-ups and different levels of the menu, and that's working pretty well and pretty responsive and quite fun to operate already, actually.
Nice.
And again, the approach from the usability side is always to see what you're doing. So there are always icons or symbols next to the buttons, like the home button is actually a house, a home. So if you press it, you immediately see that it's recognizing the operation, the color of the icon changes. When you press navigation buttons, the navigation icons, the arrows immediately change color, or the menu already scrolls automatically immediately. So it's all designed for being super immediate in operation and super clear and simple in understanding what's happening.
How easy will it be to customize this software?
Well, it's all open source, obviously. So you can, at any point, change the source code. Since there's no operating system, it's not as simple as changing scripts or configuration files on the remote currently. So you need to go into the source code and recompile the software if you want to change the operation.
No.
But since camera and remote are directly connected to each other and communicate with each other, and the AXIOM Remote also doesn't have any storage inside, where it can save user presets, for example, it would be obviously easier to store them in the camera.
Yeah.
And the AXIOM Remote could communicate with the camera and download presets, download configuration files. So in that way, you could do a lot of customization and kind of config storage from the camera with the AXIOM Remote, doing things depending on that. But that's still to be developed in the end.
All right.
Excellent.
Very, very good. Very nice. Thank you for watching this Team Talk. I hope you had a very informative view, watch, whatever. And I hope you will still tune in the next time when we come back.
We'll not do a Uranus joke this time. Just say goodbye.